Yup. 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 Just remember, kid. Oh, I smell weed. Weed. Just like Tommy. I smell. There's weed coming from that car. Oh no. Oh no. What the fuck is wrong with us? I don't know. I think I'm just mentally stupid. Those guys are in the middle of the road.
Now Talking is a former student of the Dillard Area Career Center. He graduated with a 0.1 GPA, failed all of his classes, but he turned his life around when he saved me from a burning fire. It was probably an excuse so he can graduate without having to restart another 6-year session of school. But now he has taken a new lifestyle, and now he is currently going to be. Next is we got Tommy James Clark.
My name is Tommy James Clark. Let me smoke my cigarette. Ah, man, that's some good fucking weed. Alright, well, hey, my name's Tommy. I work at a shop. I recently started my ghetto shop back in 2016, but really didn't boost up until 2020. What really happened was during the fact that I actually got arrested. I got sent to juvie for 6 years, but let me explain that story. So I used to drive a piece of shit truck, and so I talked to whoever. He asked me if he had a switchboard, and I said no. Well, what really happened after that was yeah. Oh, like, you got a question? What was your question? Yes. I made t-shirts. My t-shirts are very nice. I charge $25 a t-shirt. That's why you didn't understand. Yes, you're on the right. Oh, yeah, that's a good question. To order my t-shirts, you can go on TommyJamesClark.com, or you can go on www.tommysghettoshop.com. If you use the promo code TommyJamesClark, the first set going up.
Hello, everybody. Welcome to Launch Miss. Well, we got more launches to cover for our Rocket Miss. As we started it with Starlink at the beginning of the month, and now we got another mission. This one's pretty cool, though. So anyway, Skage, Rough Riders here, back for another rocket launch. This video stream you are currently watching is courtesy of 321 Launch. Please check them out on YouTube. Link in the description below. So 321 Launch is providing this little cool view. So anybody, this mission is pretty unique. This is like a little satellite that'll help us better discover like black holes and stuff. Yep. Sorry, Mission Control Audio is doing something right now. Stand by. Mission Control Audio is talking, and usually when it talks in SpaceX world, you gotta like. Let's see, they're talking about something here. Anyway, this is HD cam, so as usual, you'll see us showing multiple angles of the studio as we got plenty of other videos. So again, today's launch, Thomas Barkhart's NASA spaceflight in the background. Today's T0 is at 1 a.m. tonight. Is the scheduled T0 for tonight? 1 a.m. So it's a pretty late launch. Appreciate everybody staying up with us tonight. As waiting, Mission Control Audio is still saying more things here. Hang on. There we go. Put this here. Oh. Okay. Interesting. Well, anyway, so today's mission is launching from Launch Complex 39A. And we will go to SpaceX.com, and we will go through the mission together. If you want to do this yourself, you can do so by going to SpaceX.com/launches. So we're going to click Watch This. This mission's unique. It's not a Starlink mission. It's not a crew mission. It is from 39A, though, which is the same pad where Dragons launch from. But this is NASA's little communication device. So it's targeting tonight, 1 a.m., to launch a imaging X-ray explorer to low Earth orbit from 39A. 90-minute window opens at 1 a.m., but as far as we know, we're targeting the very beginning of the window. Here is today's mission timeline. So right now we're at T-minus 39 minutes, so we're getting ready to... The launch director is about to pull a go or no-go for fuel loading, because they load the Falcon 9 35 minutes prior to launch. They usually pull a go, no-go pull at T-minus 38 minutes. So we're about to get that here in just a couple of seconds here. And then obviously the rocket will start fueling at T-minus 35 minutes and then so on. Falcon 9 will enter startup at T-minus 1 minute where it pressurizes the tanks for flight, and then liftoff, of course. Max Q, first stage engine shuts off at T-plus 2.5 minutes. Second engine starts, and we go all the way to second engine cutoff. First stage will land on, just read the instructions, downrange. Now you're probably wondering, the satellite on this mission is probably the size of this iMac. It is not very big at all. But the reason why they're requiring a drone ship landing is because this is going in a very high, medium, unique orbit that requires a dogleg maneuver, which takes more fuel of the Falcon 9, which means the first stage needs to land downrange, even though the satellite's like this big. So anyway, so after the first stage engine burn completes, or the second stage engine shuts off, we're going to go into about a 27-minute coast phase, where the second engine will relight again at T-plus 28 minutes and 51 seconds to circularize the orbit, do that dogleg maneuver I was talking about. It's about a 1-minute burn, so T-plus 29 minutes and 51 seconds, and then IXPE will deploy at T-plus 33 minutes and 22 seconds. So that is today's mission timeline. So again, SpaceX is launching NASA's IXPE X-ray imaging satellite going into low Earth orbit. Well, a relatively high, but still considered low Earth orbit. But it's going in a unique orbit. It's going like launching around the equator. I'm no science expert or anything, but that's basically what we're seeing today. Obviously, the live stream will go live as soon as T-minus 20-ish minutes, I think. Oh, that's NASA spaceflight. Yeah. Unlisted. Here we go. We don't want NASA Spaceflight. If you want, NASA Spaceflight is pretty cool. You should check them out on YouTube. So this is the SpaceX live stream. Usually they set the live to go live at 1 a.m. They usually do that for the time of launch. So this is actually counting down to the time of launch. And we're getting let's see here. Mission Control just pulled a go for fuel loading, so Falcon 9 will begin loading fuel in just about 20 seconds or so, which is pretty cool. We'll get a live look here at Falcon 9 again. This is courtesy of 321 Launch down there at the press site, Kennedy Space Center. So check out, this is courtesy of them, live view of the Falcon 9 rocket. And as you can see right here, that is the first stage. As you can notice, the first stage is a little dirty. Well, that's because this first stage is going on another flight. Okay, teams are...
Respectively, we are about 635 kilometers.
Hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed into the launch abort sequence. At T-minus 10 seconds, launch control will be hands-off and rely on automated abort criteria for the remainder of the count. In the event of a fire alarm, key operators will man their post while the alarm is evaluated. In the event that personnel safety is threatened, evacuate to the south-facing emergency exit, which leads directly outside.
Okay, that's just the SpaceX launch director going through like verifications for the team. Like, this is what to do during launch. This is what to do during the mission. All that good stuff. So again, this is actually the lightest payload Falcon 9 has ever launched. And like I said before, you're probably wondering, well, if it's a very light payload, the booster can return to launch site where it can land at Landing Zone 1 at Cape Canaveral Air Force Station. Well, it's not doing that today because this spacecraft is going in a very unique dogleg maneuver orbit that I mentioned earlier, where basically it's going to go onto a low Earth orbit. Okay, launch auto sequence has started, which means the fuel loading has now begun into Falcon 9, so the venting will begin about right here where my cursor's at. So anyway, as I was saying, after it hits low Earth orbit, it's going to do a very specific orbital inclination where it has to do a dogleg maneuver, so the second stage has to basically turn to the left and go due east around the equator, which requires a lot of fuel. So even though the spacecraft's like this big, it requires a lot of fuel to make it all happen. So SpaceX has to land it downrange on a drone ship on just read the instructions. Okay, so as I mentioned before, this booster right here, as you can see, the first stage, this is the dirty part. This booster has launched Crew 1 back in November of 2020. This booster also launched the Crew 2 astronauts April of earlier this year. And it's also launched the SXM-8 satellite, a communication satellite for Sirius XM. And it has also launched NASA's Cargo Dragon resupply mission to the space station CRS-24 earlier this year. So this booster has launched 8 astronauts, 1 geostationary satellite, and a Cargo Dragon to the space station. So this booster has launched 8 astronauts, 3 Dragons, and 1 geo satellite. And today it's launching IXPE for, let's see, Crew 1, Crew 2, SXM-8. So this is going for its 5th flight today. Just shows you how NASA really trusts SpaceX on the reusability of these boosters. It's crazy. And I'm happy to see that NASA is trusting everybody. Anyway, so if you want to know the orbit we're going in today, actually, Flight Club. Let's see, there's a really cool website called flightclub.io. And this will tell you all the specific missions and the specific orbit we're going into. So let me show you what I'm talking about. So you see all this? Data. This is all the inclination, the altitude of the orbit we're going into today. This is courtesy of flightclub.io. This guy knows what he's doing. He does all the math prior to every launch. This guy is nuts. I would not be able to figure out any of this. Let's put it that way. I would never be able to figure out anything. So anyway, flightclub.io for all the orbital inclinations and data and all that good stuff. Telemetry. Here's your telemetry. Booster landings. The exact second. I mean, look, he's got the exact second in time. He's got all the mission timelines. He's got it. I mean, let's do a 3D. So this will show you the orbit that we'll be going into today. So here's the orbit we're going into today. So we're going to launch from Kennedy Space Center 39A, go around the Earth, and then this right here is what I was talking about. So we're launching due east, right? So that means your orbit would continue in this path where my cursor's at. So you see this little thingy right here? This is called a dogleg maneuver, where the second stage is going to take a big left turn and then basically change the inclination by a lot for a 1-minute burn. And as you can see, the orbit is going to go from this to this. And that's why this little spacecraft is requiring a Falcon 9, because sure, you can launch this on a small sat launcher, but it requires a lot of fuel to do this little dog maneuver right here. You're changing an entire orbit, first of all. So it's crazy. So in order to do this little dog maneuver, Stage 1 will land downrange. And this is actually how far Stage 1 is going to land, as you can see right here. So Stage 1 will burn till about here. And Stage 1 will actually coast up to apogee while Stage 2 continues on orbit. So this orange here is Stage 2. This gray here is Stage 1. It's going to go all the way and land on a drone ship. Just read the instructions. And as you can see, that's pretty far out there. I mean, look, that's like, I don't know. That's like 200 miles? It's pretty far out there. But anyway, so Stage 1 will land there, and then it'll be processed back on a drone ship. And fun fact, by the way, if you go to nasaspaceflight.com, FleetCam, the previous mission that we were live for, Starlink, is actually, the booster is actually still sitting at Port Canaveral waiting to be processed. So a Falcon 9 booster is going to launch in the background while another Falcon 9 booster is being processed for another mission. It's pretty cool. Actually, here, I'll show you here. Let's see. It's a nasaspaceflight.com. This is their YouTube right here. So they're live for IXPE too, and they got Starbase Live. Check this out. They got Starbase Live for 24/7, everything when it comes to Starship and Super Heavy. This is FleetCam, by the way. And see, this is the Falcon 9 booster that launched Starlink, and it's still sitting in Port Canaveral right now. So anyway, check out nasaspaceflight.com, click on FleetCam, and you can watch the other booster go live. Okay, so we got NASA views here. Let's see here. Okay. There we go. So as you can see, the Falcon 9 is now venting. The clouds are starting to form around the rocket as the stage is being loaded with kerosene and liquid oxygen. That is totally normal. It's not on fire. It's just venting, when you load super cold propellant into the Falcon 9, it's going to vent. It's going to get frosty. It's going to get icy. This boy is going to get a little icy. Dudge, what's up, dude? I see you there in the chat. Dudge coin to the moon. All right, let's see. We're also on Facebook here. Tom from Facebook, thanks for waking up with us early in the morning. It is 12:32 a.m. I want to go to bed. Make sure that stays up. Yeah, I want to go to bed. It's 12:32 at night. You know, we had a Rocket Lab mission earlier today, which congratulations to Rocket Lab. If you guys don't know what Rocket Lab is, Rocket Lab's another company that launched a small satellite earlier today. They launched 2 Black Sky satellites to low Earth orbit. Rocket Lab is a competitor. Well, right now they're not a competitor to SpaceX because SpaceX is a medium launch company. I know I'm saying that wrong. Anyway, it's a medium launch company. Rocket Lab's a small sat launch company. However, Rocket Lab is making a new rocket called Neutron. And that's supposed to be a competitor to SpaceX's Falcon 9, as you're seeing right here on the screen. Matter of fact, while we're here, I will show you Rocket Lab. This is that other, let's see here. The Electron Rocket, yeah. I know this is a SpaceX stream, but bear with me here. So this is Rocket Lab. This is their Electron Rocket that launched earlier today. They got a kick stage, 9 Rutherford engines. They're actually getting ready to, just like SpaceX does when they land their first stage rockets, they are actually going to land their first stage as well, but not on a drone ship. They're going to catch it with a helicopter. I mean, who the frick does that? I have no idea. Anyway, so Rocket Lab is pretty cool. They launched earlier today. So, yeah, I guess we can watch a replay. Hang on. We'll provide you more views of Falcon 9 while I cue that replay of Rocket Lab here. Let's see here. So, yeah. Tom, yeah? That's cool, Tom. I appreciate you. I appreciate you listening in or watching. Let's see here. Rocket Lab. Yeah. Okay. So this was from earlier today. This is Rocket Lab. Well, kind of keep muted. This was the rocket that literally launched like a couple hours ago. The pad mics on this mic, the pad mics on this pad is freaking amazing. Like, I'm not going to play the sound for you right now, but you got to hear the sounds. If you like sounds of rockets, oh boy, do I have a treat for you. Like, literally, this rocket is freaking cool. I love SpaceX and all, but Rocket Lab is right there behind them. So, this was the mission from earlier today. I'm just kind of showing you from earlier. Yeah, I know. That's pretty cool. Anyway, back to today's mission, the Falcon 9. As you can see, it is still being loaded with fuel. Well, I would hope it would still be loading with fuel. Or else we wouldn't be going anywhere today for the mission. Oh, yeah, you're right. Okay. That's cool. So don't forget, we actually have another live stream here on the channel. It's called Birdcam. I know, I'm doing a little self-promotion. Everybody from NASA Spaceflight, my friends on Discord can make fun of me for this. But if you go over to my channel, we also have another live stream. It's 24/7. It is Birdcam. And actually, right now, as we speak, we have a little visitor. Look at that. We have Deer currently visiting Birdcam, Ohio. This is our other 24/7 live stream that we have here on the channel. So as soon as this launch is over, check this out. This streams 24/7. At night, we get deers like you're seeing now. Possums, raccoons. Well, raccoons are in for the season, but we'll get raccoons. And then during the day, obviously, birds, cardinals, blue jays, squirrels, all that good stuff. For those of you who are a long subscriber of the channel, the right-hand camera here is actually the Barney beacon. That's why I have the camera positioned right here. Oh, actually, you can't see it. Oh, no. There. You can see a little blinking dot right there. That's the Barney beacon. So I have the camera pointed at the Barney beacon so you can see that. And then obviously we actually just installed 2 ground cameras. So we got a ground camera and a tree cam. So this is live right now on our other live stream, Birdcam Live 24/7 live stream. So check it out while you get a minute. This is so cool.
I'm gonna be the sentimental one here, but that is the rocket of my childhood.
I just love watching deer. Like, I love Mother Nature, and that's why I set up live cameras. Also, DOS from NASASpaceflight.com inspired me to put cameras everywhere because that's what they do over at Starbase, Texas. So I just put cameras all around my backyard to look at wildlife. So, oh, you got a little spook there. He's like, DOS, no! Anyway, so that is currently live right now on BirdCam. So if you have like a split screen, you can put this rocket launch stream on your main screen and then put BirdCam on another live stream. So, he looks like he's dipping. Never mind. He heard me. He's like, oh, they're watching me. Anyway, so BirdCam Ohio, my other live stream, is currently live right now. Check it out, 24/7 stream on the channel. Back to today's mission. Falcon 9 is still venting, getting ready for the T-minus 20 vent, where the transporter erector will start venting some stuff, where it'll start venting like it's pissed off. That's a good question. I know NASA is already live. Do they already have are they having their own? Let's see here. Oh yeah, they are live. Yeah, SpaceX is doing a separate live stream from SpaceX here. Huh. Okay. All right, well, NASA has a separate live stream, so you could check them out. But we're here to watch SpaceX live streams because they're best.
And there is our big vent right.
All right.
20 minutes, 25 seconds, as expected. So this is just them purging the transporter erector lines, getting everything nice and inert, so there isn't an accidental ignition source left within it when our liquid oxygen begins flowing into the second stage here in about 4 minutes.
All right. All right, so this is that T-minus 20 vent I was talking to you guys about. That is the transporter erector, basically just venting all its propellant lines and all that stuff. Anyways, I'm going to take a brief intermission here. I'll let you guys watch the rocket. I'll put HD cam up, our mission control cam. Oh, SpaceX is live. All right, well, we're going to get ready here for some action. All right. Stay tuned, everybody. SpaceX Live will be live in just a few moments. So again, this is totally normal. The rocket is just venting its fuel. The wind is making it look kind of unique. It's pretty cool, actually. SpaceX live stream starting.
Good evening and welcome to our launch cover in Florida. Good evening and welcome to our launch coverage for IXPE, or the Imaging X-ray Polarimetry Explorer for our customer NASA. My name is Shiva Bharadwaj, and I'm a space operations engineer, and I'm joining you from SpaceX headquarters in Hawthorne, California. The Imaging X-ray Polarimetry Explorer is NASA's first mission dedicated to measuring the polarization of X-rays from a variety of cosmic sources, objects like black holes and neutron stars. We'll have a little more on the science IXPE will conduct a bit later on in the webcast, but for now, let's take a closer look at the rocket on your screen. This is Falcon 9, our two-stage liquid-fueled launch vehicle. It's standing vertical at Launch Complex 39A. Now, the booster supporting today's mission is flying for the 5th time, and this also marks SpaceX's second flight-proven launch vehicle for NASA's Launch Services Program, or LSP. Now, this booster first flew in November of last year. It since has carried 3 Dragons and 8 astronauts to the International Space Station on the Crew 1, Crew 2, and CRS-23 missions. It also flew the Sirius XM-8 satellite to orbit earlier on this year. Now, if you're new to our webcast or unfamiliar with the Falcon 9, that bottom 2/3 of the vehicle is what we refer to as the first stage. It's covered by some white clouds around it, but it's also covered in some soot from its previous flights that you might catch in between. Now, the first stage's primary role is to accelerate all the way to the edge of space with the help of 9 Merlin engines that it has at its base. There, it'll drop off the second stage and the payload. Then, the first stage will make its way back to planet Earth, where we'll attempt to recover it on our autonomous drone ship named Just Read the Instructions. Now, if you turn your attention back to that section above the first stage and above that black carbon fiber interstage, you'll see Falcon 9's second stage. About 2.5 minutes into the flight, the stages will separate. The second stage will ignite its single Merlin vacuum engine and carry itself and the IXPE payload into a circular orbit. Now, if the launch wasn't cool enough, IXPE also marks the first Falcon 9 launch into an equatorial orbit. That means that the satellite will fly into an orbit that goes along the equator, which we refer to as having an inclination of about 0 degrees. Getting to an equatorial orbit from Florida requires a lot of rocket performance and propellant, so we won't be able to land the first stage back on land. Instead, we'll attempt to land the first stage on our drone ship stationed off the coast of Florida, while the second stage completes its orbital insertion burn. Now, the second stage will perform a second burn about 20 minutes later to get to that final circular equatorial orbit, followed shortly after by satellite deployment around T+33 minutes. Today's mission also marks the smallest dedicated payload that a Falcon 9 rocket has ever launched by a pretty large margin, making for a very roomy payload fairing at liftoff. Now, speaking of which, the fairing is that nose cone structure at the very top of the vehicle above the second stage. The fairing protects the IXPE satellite from aerodynamic heating, loads, and contamination during the ascent portion of the mission. Now, it's made of 2 fairing halves. Both of those are brand new today, and we're planning to recover them on a recovery ship named Bob, which is stationed out in the Atlantic Ocean. Now, we're coming up on about T-minus 12.5 minutes to liftoff. The launch vehicle and satellite teams are continuing towards an on-time liftoff scheduled for 1 a.m. Eastern Time. Falcon 9 team began their final checks at about T-minus 2 hours. Most recently, we completed the ground team poll to proceed with propellant load and launch that happened at T-minus 38 minutes. We began loading propellants at the T-minus 35-minute mark. Falcon 9 is a bipropellant vehicle. That means we have 2 propellants on board, a fuel and an oxidizer. For
Falcon 9, our fuel is a refined form of kerosene that we call RP1 or rocket propellant 1. And to burn that fuel, we need an oxidizer. On Earth, most combustion or burning uses oxygen from the atmosphere as its oxidizer, and that oxygen makes up about 21% of the air that you and I breathe. However, in space, we don't have an atmosphere to provide that oxygen or other oxygen-bearing molecules, so rockets need to carry their own. On Falcon 9, the oxidizer is super-chilled liquid oxygen, what we call densified LOX, and we chill it well below its boiling point, which increases its density and allows us to load more onto the first and second stage LOX tanks. Now, currently, we are fully loaded on fuel on the second stage. Fuel loading is underway on the first stage. That'll continue about until T-minus 6 minutes when it will complete, and liquid oxygen loading is loading on both the first and second stages and causing those plumes that you see around the vehicle. Now, once fully fueled, Falcon 9's first and second stage combine to carry over 1.1 million pounds of propellant, and we'll burn through most of that in the about 8.5 minutes that it takes to land the first stage and to get that second stage into its initial orbit. We'll also need an igniter to burn that fuel and oxidizer, and for that we use a chemical called TTEB, that stands for triethyl aluminum and triethyl borane. When it combines, it produces a characteristic green flash that we can sometimes see at the base of the vehicle, and that ignites our Merlin engines. Then those Merlin engines, the 9 at the bottom of the first stage, will begin throwing out their combustion exhaust out of nozzles at the bottom of the rocket, and that pushes the vehicle in the opposite direction. It's a great example of Newton's third law of motion. For every action, there's an equal and opposite reaction. Now, quick update on the weather. We started the day with a 10% probability of violating launch weather requirements. That is to say that we have a 90% chance of go. Been listening to the loops, and we aren't tracking any significant issues that would expect us to hold towards today's launch at 1 a.m. Eastern Time. The weather conditions also look good for booster landing on our drone ship and for fairing recovery out in the Atlantic. So with that, the launch vehicle, satellite, weather, and the range are looking good to go for that 1 a.m. Eastern Time liftoff from Launch Complex 39A. Now, as I mentioned earlier, today's IXPE mission is for our customer NASA, and it's the first NASA Launch Services Program mission being launched from Launch Pad 39A. But it also marks SpaceX's 5th as part of the NASA Launch Services Program missions. Those science missions include the Double Asteroid Redirect Test mission that we launched a few weeks ago, the Sentinel-6 Michael Freilich mission in 2020, the Transiting Exoplanet Survey Satellite launched in 2018, and JASON-3, which launched in 2016. But our payload tonight is a collaboration between NASA's Marshall Space Flight Center, the Italian Space Agency, and Ball Aerospace. The Imaging X-ray Polarimetry Explorer will help us understand fundamental physics of some of the most energetic cosmic objects in the universe by studying the special properties of the X-rays that they emit. NASA's Tiffany Russell Lockett will give us a closer look at the main components of IXPE, where those X-rays come from, and how studying their polarization will help us better understand the universe in the years to come.
To answer some of the biggest questions about what's out there in the universe and what it all means, we need powerful telescopes. NASA unravels the mysteries of the cosmos using observatories in space that study the different wavelengths and properties of light. The Imaging X-ray Polarimetry Explorer, or IXPE, will study X-rays from some of the most extreme objects in the universe, like black holes, in a new way. IXPE will look at a special property of X-rays that has gone mostly unexplored until now. It's called polarization. X-rays come from the hottest places in the universe. Imagine powerful explosions, violent collisions, and strong magnetic fields creating chaos in the darkness of deep space. X-ray telescopes can trace clouds of gas heated to millions of degrees and detect the shower of particles fueled by a feeding black hole. Building on the discoveries of NASA's Chandra X-ray Observatory and other space telescopes, IXPE measures the orientation of X-rays from some of the most brilliant and bizarre objects in space. Like all forms of light, X-rays consist of moving electric and magnetic waves. Usually, the peaks and valleys of these waves move in random directions. Polarized light is more organized, with the two types of waves vibrating in the same direction. You might have heard of polarized sunglasses. Boaters and fishermen use these lenses to reduce glare from sunlight across a body of water. Water reflects light in a way that causes some of it to vibrate in a direction parallel to the water's surface. Polarized lenses block light moving horizontally, but let other light through. Much like the way light changes when it bounces off of water, in space, light becomes polarized depending on where it comes from and what it passes through. By measuring the amount and direction of polarization, IXPE gives us clues about the shapes, structures, and inner workings of all types of objects that shine in bright X-rays. The IXPE Observatory has 3 identical telescopes with 3 main parts: mirrors, detectors, and an extendable mast, or boom, that separates them. Each mirror assembly contains 24 nested mirrors that collect and focus X-rays. Located at the focal point of the mirrors, sensitive detectors made with international partners in Italy are the secret behind IXPE's unique X-ray vision. They track and measure all 4 properties of incoming light: its arrival time, direction, energy, and most importantly, polarization. Over the 2 years of its prime mission, IXPE will observe more than 50 brilliant objects, like the leftovers of huge stars that exploded into supernovae, the supermassive black hole at the heart of our own Milky Way galaxy, and pulsars, the dense remains of stars that once were. These observations will help scientists tackle long-standing puzzles, like testing competing theories about pulsars and the details of how Einstein's theory of general relativity works. New insights from IXPE will help us paint a fuller picture of the universe, confirming or confounding our thinking in the years to come.
Now we're just over T-minus 4 minutes away from liftoff of the Falcon 9 carrying the IXPE satellite. You can see the strong back arms, the clamp arms that are around the second stage are starting to open. Those are attached to a structure, that truss structure called the Transporter Erector, or the TE. And in preparation for launch, we'll open up those clamp arms. The Transporter Erector will slowly retract away from the stage. As we get closer to T-minus 0, ground hydraulic systems will further pull the TE away, clearing the way for Falcon 9 as it proceeds into its liftoff. We refer to the Transporter Erector sometimes as the strongback, and you heard that call out on the loops. Now, the Transporter Erector is used to roll Falcon 9 out to the launch pad and raises it into the vertical launch position. It also routes power, fluid, and communications to both the rocket and the satellite. We just heard a call out there for some of those fluids that completed loading on the first stage. We completed loading all propellants on Falcon 9's first stage. Now, the first stage is connected to the base of that Transporter Erector by a hinge structure, and again, that'll retract further away from the vehicle in preparation for launch. The white gas that you're seeing around
really working with a lot of increased technology to help us both examine things with how.
Come on! What's going on, computer? Oh, is it doing that really fast play shit? Come on. The reason it does a fast shit requires
And then the next activity after will happen around T-minus 60 seconds when Falcon 9 transitions to internal control via its autonomous flight computer. Started. Now, once Falcon 9 has taken over the launch countdown, it'll continue to have control of Falcon 9 through the rest of the mission. The launch director will give their final go for launch if all conditions continue to look good, and then at about T-minus 2 seconds, we'll ignite those 9 Merlin 1D engines for liftoff.
Falcon has some startup.
So with that, the IXPE satellite continues to look healthy. Falcon 9 team is tracking for the last 30 seconds. Let's listen in as Falcon 9 takes IXPE into orbit.
Here we go!
The launch director has given
lift off!
T-minus 15 seconds.
30 seconds of the terminal count.
T-minus 15 seconds. 10, 9, 8, 7,
Let's listen in as Falcon 9 takes
4, 3, 2, 1, 0. Ignition. Go Falcon. Proceed. IXPE. Nominal first stage chamber pressure. Liftoff. Go Falcon. Go proceed. IXPE.
That's what I want to do. Fleet cam! Look at that!
Nominal first
Nice.
stage chamber pressure.
Look at that, another Falcon 9 launching over another Falcon 9. Look at that, there's a Falcon 9 currently sitting here on That was a quick countdown, jeez!
aerodynamic pressure. That's coming up in about 10 seconds.
Vehicle is supersonic.
SpaceX stream is behind, that's the space flight's ahead.
Fax key.
So with that, we are through the highest stresses on the vehicle from the combination of our increasing velocity and the decreasing atmospheric density. Coming up next, the next event in about a minute will be MECO, that's main engine cutoff. We'll shut down those 9 Merlin 1D engines in preparation for the next event, stage separation. The first and second stages will separate, and then at about T plus 2 minutes, 44 seconds, we'll have SES-1, second engine start number 1. That's where the Merlin vacuum engine on the second stage will ignite to carry the second stage and the IXPE payload into orbit. So again, those 3 events coming up in succession: MECO, main engine cutoff, followed by stage separation, and then SES-1. And this view, looking down on the Merlin 1D engines from the first stage, you can see the plume expanding as the atmospheric density drops off to get higher and higher in our atmosphere. MECO, main engine cutoff, followed by stage separation, and then SES-1. And this view, looking down on the Merlin 1D engines from the first stage, you can see the plume expanding as the
Get ready for stage separation, where stage 2 is about to fire. MECO.
Stage separation.
Stage separation.
And back ignition.
So those three events successful: main engine cutoff, stage separation. Left-hand side of your screen, you can see a view of the first stage deploying its grid fins, starting its recovery sequence. The second stage on the right-hand side of your screen, we've got a shot of the Merlin vacuum engine glowing as it continues its ignition to carry IXPE into orbit. Next major event coming up will be fairing deployment. At this point, the second stage...
Stage 2 on trajectory.
The second stage is getting to a part of the atmosphere with very low density, so we don't need to carry those fairing halves anymore. We can jettison them back to planet Earth and then attempt to recover them. Again, both of them being new fairing halves flying for this mission.
Fairing separation confirmed.
Look how small the payload is.
There's confirmation on the fairing deploy.
That is like the
IXPE
smallest
satellite
fucking
now getting
payload.
directly exposed to the vacuum of space.
Dude, this spacecraft looks so silly.
Attempting to recover those with a recovery vessel named Bob, which is out in the Atlantic Ocean.
Hey, when you're doing dogleg maneuvers, you need all the performance you can get. Doesn't matter if it's a small ass spacecraft.
So if you're just joining us, welcome. We're about T plus 4 minutes and 20 seconds into today's mission.
Acquisition of signal for MENA.
On your screen is a view of the Merlin vacuum engine on the second stage. It's completing its first of two planned burns to take the IXPE satellite into an initial parking orbit. We had an on-time liftoff at 1 a.m. Eastern Time. The first stage that carried the second stage this far separated and is on its way back to planet Earth. Its next major activity will happen at about T plus 6 minutes and 20 seconds, and that'll be for the entry burn, where it'll ignite a few of its engines to slow down in preparation for entering the Earth's atmosphere. Now, during the entry burn, we'll relight 3 of the Merlin 1D engines on the first stage. That'll start with the center engine, followed shortly after by 2 of the side engines. That'll slow down the vehicle as we pass back into Earth's atmosphere. And we need to slow down on the first stage to reduce the entry forces, which helps us recover and reuse that first stage. Reusability is a key part of lowering the cost of spaceflight, which enables more investment into the critical scientific hardware and research. Now, Falcon 9's first stage that supported today's mission will perform this entry burn for the 5th time, having previously done so for the Crew 1, Crew 2, Sirius XM-8, and Sirius 23 missions. And those brand new fairing halves will also re-enter Earth's atmosphere for the first time. The second stage, continuing to burn, its burn will continue until
entry burn! Look at that!
We've heard periodic callouts that we are seeing nominal performance and following a nominal trajectory on the second stage.
That's cool.
Stage 1, entry burn.
The left-hand side of your screen, you can see the grid fins and you can see the plume from the entry burn. At this point, we are firing 3 of the Merlin 1D engines. And
it's crazy how Chris G
decelerating the
had
first
it.
stage, but we're still going pretty fast. So as we're flying into the Earth's atmosphere, that soot is actually getting kicked back, excuse me, the plume is getting kicked back
Stage 1, entry burn. Check down.
onto the first stage. And the plume is carbon-based, so that'll deposit a nice layer of soot on
Stage
the
1's
first
on its way back.
stage.
5 flights.
Nominal shutdown of the entry burn. The next activity for the first stage will be the landing burn. That'll happen at about T plus 8 minutes and 10 seconds. Second stage continuing to look nominal. Now the engines on both the first and second stage are different. The Merlin engines on the first stage are optimized for sea level thrust, but the Merlin vacuum engine that you see on your screen is optimized for vacuum. And the difference there is how much which we can expand the pressurized gases that are being produced by the Merlin engine. Call out there for stage 1 being transonic, so it's transitioning from supersonic speeds back to subsonic speed. The next events coming up will be second engine cutoff number 1, that's shutdown of this Merlin vacuum engine, and pretty close after we'll hear call out for landing burn startup on the first stage.
Stage 1 landing burn.
And back engine cut off.
The shutdown of the Merlin vacuum engine.
Oh,
We've got
shit.
landing
All
burn
right,
startup
stage 1.
on
Here we
the
go.
first stage. Left-hand side of your screen is a shot from the drone ship.
Oh, baby.
Stage 1 landing leg deploy.
And correction, that's a shot from the first stage. And on the right-hand side is a shot from the drone ship. We've deployed the landing legs, hopefully for a soft touchdown on Just Read the Instructions.
Yeah!
And that
Flight number 5 complete.
97th successful recovery of a first stage on our drone ship named Just Read the Instructions. This particular first stage having scored 5 flights under its belt. Now the mission isn't over just yet. The second stage on your screen is now embarking on its first coast phase, and it's in its nominal orbit. So after this coast phase, we'll light the Merlin vacuum engine for a second time around T plus 29 minutes to put it into the final circular orbit for payload deployment. We'll see you back here in about 20 minutes, but in the meantime, enjoy the space jams and the views of the stages. After this coast phase, we'll light the Merlin vacuum engine for a second time around 29 minutes to put it into the final circular orbit for payload deployment. We'll see you back here in about 20 minutes. In the meantime, enjoy the space jams and the views of the stages.
All right, so now we're in a coast phase. We're going to be coasting until about T plus 28 minutes, until stage 2 will fire up for another minute. To place it from its diagonal orbit into an equator orbit, it'll do that dogleg maneuver. It's going to be a 1 minute burn. So that's coming up in about 25 minutes from now. NASA's got tons better get out. This is a live view of bird cam right now. A deer is approaching. Well, nope, never mind. We scared him away. Bird cam is our other 24/7 live stream, currently streaming on the channel. Check this out. Check the bird cam live after this stream has ended. So, oh, he's coming back. Bird cam Ohio, 24/7 live stream. You can watch live views of deer like this.
Seen many launches in my career. Picture perfect. It means so much to me. I almost can't describe the feeling. Just I know excitement, and I'm looking forward to the next 30 days when the lecture works and start taking off. But this was a beautiful use of SpaceX people was doing last year. As everybody involved in this thing, it's been
Look at that orbit change. So you see on your screen, right here, look at this. This thing has to go from a circular orbit to that orbit. Like, look at that. That's a big orbit change. Even though it's a small spacecraft, they got to change the velocity by like a shit ton. That's crazy. One more view of bird cam. Again, if you want to watch this deer, what he's doing when I'm not showing it on this stream, check it out on our other live stream. It's a 24/7 bird cam. Check it out on the channel, currently streaming now. Live views of the second stage again. Bye-bye, Ice Piece.
In the Falcon 9 mission carrying the Imaging X-ray Polarimetry Explorer, or IXPE satellite for our customer NASA. We've had a great mission so far. The Falcon 9 launched on time at 1 a.m. Eastern Time from Kennedy Space Center. We successfully recovered the first stage, and the second stage completed its first burn, taking the IXPE satellite into its initial parking orbit. Now we're just about 10 or so seconds away from a second ignition of the Merlin vacuum engine that'll carry the second stage and the IXPE satellite into the final payload deployment orbit. So that second burn, called second engine start number 2, coming up shortly. And that's seconds away from a second ignition of the Merlin vacuum engine. So there's ignition of the second stage engine. This burn was expected to last about 40 seconds. Now, the initial orbit that the the second stage went into put it at about a 28-degree inclination with a high apogee and a fairly low perigee. This burn is taking us down to 0 inclination. That means we'll be flying over the equator, and it'll put us into a circular 600 by 600 kilometer orbit. You're looking at live views of the Merlin vacuum engine and some photobombs from planet Earth behind it. This burn is taking us down to 0 inclination. Okay. Flying over the equator, and it'll put us into a circular 600 by 600 kilometer orbit. You're looking at live views of the Merlin vacuum engine and some photobombs from planet Earth behind it.
Okay. And shutdown.
Nominal and got cut off.
With that, the second stage engine, the Merlin vacuum engine, has shut down. The launch team will be reviewing the orbital parameters.
Nominal orbit insertion.
And with that call out, we are in the expected circular orbit right above the equator, about 600 kilometers above the Earth's surface. Now, as a reminder, the IXPE satellite is still attached to Falcon 9's second stage. We've got payload deployment coming up at about T plus 33 minutes. We are in the expected circular orbit right above the equator, about 600. Now, if you're just joining us, we had an on-time launch at about 1 a.m. Eastern Time, followed by successful ascent and stage separation. We successfully recovered our first stage, and we've completed 2 second stage burns. And the booster, and actually there's a live shot of the second stage and the IXPE satellite above planet Earth, currently over Africa. Now the booster that supported the IXPE launch today successfully landed for the 5th time on our drone ship named Just Read the Instructions, that was stationed out in the Atlantic Ocean off the coast of Florida. Reusability is a key part of SpaceX's mission to increasing the access to space. And we also had brand new fairing halves on today's mission. We'll be attempting to recover both of those on a recovery vessel named Bob. That is another great shot of NASA's Imaging X-ray Polarimetry Explorer, or IXPE. This mission is the first satellite that's dedicated to measuring the polarization of X-rays coming from high-energy objects like black holes and supernova. It's the first NASA Launch Services Program mission that's ever been launched from the Launch Pad 39A, an historic launch pad at Cape Canaveral. And it's SpaceX's fifth as part of that program. This program helps launch spacecraft to observe planet Earth, visit other planets, and to explore our universe. Now, the IXPE satellite does mark also Falcon 9's first launch to an equatorial orbit. The satellite is currently in a 0-degree inclination orbit above our equator at about 600 kilometers above the Earth's surface. About a minute away from payload deployment. And once we get into payload deployment, the IXPE satellite will then get to proceed with its 2-year mission. Now, IXPE is an orbital observatory. Its job will be to study the laws of nature on astrophysical objects that we can't recreate in labs here on planet Earth. So we'll use the telescopes on IXPE to observe them in parts of our universe. Over the next month, the satellite team will conduct checkouts of the vehicle. They'll extend a boom that holds 3 telescopes on the satellite, and then they'll start observing some of those astrophysical objects. The first one will be a supernova remnant, so the remains of a stellar explosion in the Cassiopeia constellation. It's an object that's about 11,000 light years from planet Earth. Separation confirmed. There's confirmation of payload separation. The IXPE satellite floating away from Falcon 9's second stage to begin its 2-year mission to study some of the most energetic objects in the cosmos. And with that, it's going to end our webcast coverage for today. So we want to give a big thanks to NASA for entrusting us with today's mission, SpaceX's 5th NASA science mission to date and the 2nd in the last couple of weeks. We also want to give a big thanks to the Range and the Federal Aviation Administration for supporting today's mission. And of course, thank you for tuning in, and we'll see you again for the next launch. Big thanks to NASA for entrusting us with today's mission, SpaceX's 5th NASA science mission to date and the 2nd in the last couple of weeks. We also want to give a big thanks to the Range and the Federal Aviation Administration for supporting today's mission. And of course, thank you for tuning in, and we'll see you again for the next launch.
Launching the payload, the spacecraft drift away. Oh! Look at that! The solar panels deployed. Whoa, did you see that? That was cool. Did you see the solar array just went? Wow, that was cool. I think they're gonna wait until it drifts out of frame. Yep, that's exactly what it is. That was cool.
Due to the fact that the low rate spacecraft, depending on where it's at, we may not get full health data until full health data. We're waiting to get the separation signal, at least to make sure we know, establish communication with the spacecraft.
can see from that track right there, that's the location of stage 2. It gives you a rough approximation of where IXPE is as it continues on its orbit. Kenya, of course, just right there at the edge of that track, that's where our ground station is. If for some reason we can't pull it in through Malindi, we have a backup station in Singapore.
Yeah, it's true. We've got ground stations all across the orbit to make sure that we can communicate with the spacecraft while it's on orbit. But the primary ground station being that one in Malindi, as we talked about earlier, this equatorial orbit allows them to orbit around Earth, and every time they make an orbit around Earth, they come over that same
NASA for
Malindi.
SpaceX.
They're able to download their scientific data and share that with the community. It allows them to continue getting more data each time, making sure that they have everything they need, and checking on the spacecraft every single orbit.
And for those just joining us, we are T plus 37 minutes.
Assistant managing editor of NASASpaceflight.com.
And 30 seconds into flight, we are awaiting the acquisition.
My absolute pleasure. Would not have been anywhere else. Happy to see it.
So we're still waiting to hear about acquisition of signal as they continue to work their processes and procedures. The spacecraft team is actively waiting to hear from IXPE as they communicate with it.
We are actually listening to communications between the spacecraft team and the launch team, monitoring them to see when that acquisition of signal comes through.
As you can see there on the graph that stage 2 continue, and IXPE continues to move on its way around that equatorial orbit.
Good to try to launch again, and always good to see a new scientific explorer.
And for those who haven't heard the early part of the show, IXPE stands for Imaging X-ray Polarimetry Explorer. This is a spacecraft that, for the first time, will help astronomers discover hidden details of some of the hottest,
We'll wait till
densest, and
spacecraft
most extreme
acquisition
cosmic
signal
sources,
before wrapping up our live coverage here.
black holes, through supernova, and active galactic nuclei.
I think that's going to become a popular pop culture phrase.
Active galactic nuclei?
I do. I think scientists are going to make that come back.
The AGN.
Yes, but I'm so happy for the science team, and I know they're excited to study all of this, and as we continue to monitor the spacecraft team, and they're following all their procedures, following the checklist, waiting to confirm acquisition of signal, and we'll continue with the mission.
Got some good news.
Yep, that is correct, Daryl. We are hearing from the spacecraft team as they are talking to NASA's launch manager, Tim Dunn, that they have acquired the signal of IXPE from the ground station, and everything looks good on board. So congratulations to the IXPE spacecraft team. That was a moment I know they were waiting for, and I'm so happy to hear that they are communicating with their spacecraft.
Yeah, we waited for that confirmation to come through. We could hear the spacecraft team in our audio loops, as they call them, celebrating. There was a round of applause. There was some clapping. Certainly a neat moment to hear. Sorry we couldn't share that with you, but it's certainly something.
All right, everybody. Well, that's going to do it for my live coverage here for the NASA SpaceX IXPE mission. Looks like the teams have successfully acquired signal with the IXPE spacecraft. The SpaceX Falcon 9 rocket did its job, placing it in the exact orbit it was supposed to be in. And NASA teams have acquired signal to the IXPE spacecraft. So with that, guys, it is 1:41 a.m. in the morning. I'm going to get on out of here. If you're going to stay up, check out our other live stream, BirdCam, which is live 24/7. You can watch deer, raccoons, all that stuff, all of our night critters that happen. And then, of course, during the day, you get birds. So check out Bird Cam, our 24/7 Bird Cam stream. I'm already losing my voice because I'm tired. So have yourselves a wonderful night. And, what'd be funny is if I actually got the thing prepared. That may actually work. Anyway, have yourselves a great night. We will see you again next time. Goodbye, everybody.